Mr. Wright here, and welcome to my run-through of the mixed exercise at the end of the circles chapter. That's chapter number 6. If you find this film useful, please do hit like and give me some positive feedback. If you've got any questions, do leave them in the comments, and of course I'll respond. And if you are studying maths in the sixth form, perhaps you should subscribe. Right, let's get on with the maths. Question 1. We're told that QR is the diameter of a circle, and we're told the coordinates are point P. So I've written all that information down. Right. We're told that QR is the diameter, and in part A, we're asked for the centre of the circle. Well, the centre of the circle will simply be the midpoint of Q and R. So I'm simply going to add together the two coordinates and halve them. Gives me a centre at 3, 6. In part B, I'm asked for the radius of the circle. Well, the radius of the circle is going to be the distance between one of the ends of the diameter. I'm going to take Q and the centre of the circle. So we need to find the distance, the length between the centre and the edge. So I'm going to use the distance formula. So D is going to be, right, D 12 minus 6 squared plus 11 minus 3 squared. There we go, it's going to be the square root of that, which is the square root of 6 squared plus 8 squared. I've got a 6, 8, 10 triangle, haven't I? Which is the square root of 100. So the distance between the points is 10, and so the radius of my circle is 10. Okay. Write down the equation of the circle. Well, I know the centre and I know the radius, so my equation is going to be x minus the x coordinate of the centre plus y minus the y coordinate of the centre equals the radius squared. Show that P lies on the circle. Right, well, let's see if the point P satisfies this formula. So our formula is x minus 3 squared plus y minus 6 squared. And apparently, when we put the coordinates of P in there, apparently we're going to get the answer 100. Let's have a look. The distance of P from the centre is apparently 100. Let's see. 30 minus 3 squared plus 6 minus 6 squared. Well, that's 10 squared plus 0 squared. So, that is 100. So, P is on the circle. And what we've actually found is that the distance of P from the centre is 10. So we found that the P is on the circle. All right, that is question 1 sorted. In question 2, I'm asked to show that the point 0, 0 lies inside this circle. Well, let's evaluate x minus 5 squared plus y plus 2 squared when x equals 0 and y equals 0. If our answer is 30, then the point 0, 0 lies on the circle. If the answer is greater than 30, then the point 0, 0 is outside of the circle. And if the value is less than 30, then the point 0, 0 lies inside the circle. So I've simply substituted in here. 5 squared is 25, plus 4 is 29. Right, so because x minus 5 squared plus y plus 2 squared is less than 30, 0, 0 lies inside the circle. There we go, that's question 2 done. In question 3, I've given the equation of this circle, and in part A, I'm asked to find the centre and the radius of the circle. So what I'm going to do is I'm going to rearrange this formula so that it is ready for me to do a bit of completing the square and then to rearrange it into the general form for the circle formula. So I'm going to subtract 3x from both sides, these with no x's on the left. I'm going to add 2y to both sides, and I'm going to leave the minus 7 over there. Right, so to turn this into the form that I'm used to. I'm going to complete the square here on the y's, and then I'm going to add 16 to both sides. Okay, so now I can read off the centre of the circle will be 0 minus 4, and the radius of the circle is the square root of 9, which is of course 3. Okay, part B. In part B, I'm asked to find the intersection of the circle and the y-axis. If it's dealing with the intersection of the circle and the y-axis, I'm dealing with x equals 0. So that means that I'm going to substitute x equals 0 into the equation of my circle. So I'm going to end up simply with y plus 4 squared equals 9. Well, in that case, square root both sides, y plus 4 is going to be 3 or minus 3. And so y is going to be minusing 4 is going to be minus 1 or minus 7. So my points of intersection are going to be 0, minus 1, and 0, minus 7. So that is where the circle crosses the x-axis. Right, part C, show the circle does not intersect the x-axis. Well, let's have a look. If I'm interested in an x-axis intersection, then I'm going to look at y equaling 0. Here's the equation of my circle. And I'm going to put in y is 0. So I've got x squared plus 4 squared has to equal 9. X squared plus 16 equals 9. Just a moment, that means that x squared would have to be minus 7. Well, there aren't any real solutions to that equation. No real solutions. So circle does not intersect the x-axis. Okay, that's question C done, and that is the end of question 3. Question 4. I've got 2 circles here, and I'm told that the centres are P and Q respectively. So the centre of this top one, P, is 8, 8. And the coordinates of Q, the centre of this one must be minus 1, 3. Okay. Let's look at part A. Show that P, which is the centre of the top circle, lies on the second circle, this circle on the bottom. So I'm going to evaluate this and see if I get 106. And if I do, then the point P does indeed lie on that circle. 8 minus 3 is 5, gives me 81 plus 25, which is 106, which is what it was supposed to be, looking at the equation of that circle. So I can say that the centre of that top circle, P, does lie on this bottom circle here. And that's interesting. So the centre of one circle lies on the other. Okay, right, part B. I wonder if we're going to use that fact. I've got to find the length from the centre of one circle, PQ, from the centre of one circle, P, to the centre of the other circle, Q. Now, I suppose I could just, I've got the coordinates, I could just use my distance formula and find the distance between P and Q. But let's see if I can do it more intelligently, given my answer to A. So let's draw a diagram. So in A, we've got the point P, haven't we? It's going to be this point here. And we've got the point Q. It doesn't matter where we put Q. Let's put Q here. And we know that P is the centre of a circle. Okay, very good. Right, not a very good drawing. And we know that Q is the centre of a circle. And P lies on that circle, doesn't it? So this is the second circle with Q at the centre. And we're asked to find the distance PQ. Well, look, that distance is simply the radius of this second circle, isn't it? So it's simply the radius of the circle x plus 1 plus y minus 3 squared equals 106. It's the radius of that circle, in which case the length PQ That's equal the radius of that circle, which will be the square root of 106. That's question 4 done. Question 5. I've got 3 points, and I'm asked to show that they lie on this circle. So let's take point A to start with, and let's see if the equation of the circle is satisfied. So apparently, my x-coordinate squared plus my y-coordinate squared should equal 1. Let's have a look. Well, in A, it does. Let's have a look at point B. So my x-coordinate squared plus my y-coordinate squared. Well, a half squared is a quarter, plus root 3 times root 3. 2 for 2 is 4. Aha, look at that. That equals 1, 2. And let's look at point C. Well, point C is a half squared plus minus root 3 over 2 squared. Well, that's the same as the calculation in point B, isn't it? Since minus root 3 over 2 squared is the same as root 3 over 2 squared. So that's going to equal 1. So there you go. Part A done. Part B, I've got to show that ABC is an equilateral. So I'm going to find the distance, the length of AB. I'm going to find the length of BC. And I'm going to find the length of AC. And if they're all the same, then I'm dealing with an equilateral triangle. So let's have a look at that. So AB, the distance from AB is going to be the square root of the difference in their x-coordinates plus the difference in their y-coordinates. Okay, so that is the square root of 9 over 4 plus 3 over 4. So that's the square root of 12 over 4. So that's the square root of 3. Right, so that's the distance AB. Right, let's have a look at the distance BC. The square root of the difference in their x-coordinates plus the difference in their y-coordinates. Let's see what that equals. That's the square root of 2 root 3 over 2 squared is 2 root 3 times 2 root 3, which is 4 times 3 over 4. That's the square root of 12 over 4, which is the square root of 3. It's looking like it might be an equilateral triangle. Let's just check the distance from A to C. The square root of the difference in the x-coordinates squared plus the difference in the y-coordinates squared. Well, this calculation is exactly the same as the AB calculation, isn't it? So that's going to be the square root of 12 over 4, which is the square root of 3. So AB equals BC equals AC implies ABC is equilateral. And that's my answer for question 5. Question 6. I've been given the equation of a circle here, and I'm told it passes through the point 3, 0, and I'm asked to find 2 possible values for k. Well, if the circle passes through the point 3, 0, then the equation is satisfied when x is 3 and y is 0. So that's going to be, when x is 3, that's going to be 3 minus k squared, plus if y is 0, I'm going to have minus 3k squared, and that has to equal 13. So let's continue with that. 9 minus 6k plus k squared plus minus 3 squared is 9k squared, has to be 13. Let's settle this equals 0 and factorize it, shall we? So we're going to have 10k squared minus 6k. I've got the minus 9. I've got the 9, and I'm minusing 13 from that, which is going to give me minus 4, and that's going to equal 0. I can divide everything by 2. Gives me 5k squared minus 3k minus 2 equals 0. Right, can I factorize this left-hand side? I know it's got to be that. I know it's got to be a 1 and a 2 there. So looking at that, it's going to be 5x plus 2 and k minus 1. Just give that a quick check. from the middle there, I'd get 2 times k is 2k minus 5k. That works. Good. So my solutions for k, k would be minus 2/5 or 1. Okay. So those are my two solutions for k. Right, part B. Okay, part B then. So in part B, I'm told that k is greater than 0. Right, so that means that therefore k must be 1, mustn't it? All right, write down the equation of the circle. Well, I know the equation of the circle was x minus k squared plus y minus 3k squared minus 3k squared equals 13. And I now know that k is 1, so that's going to be x minus 1 squared plus y minus 3 squared equals 13. So there is the equation of the circle, and that is question 6 complete. Question 7. I've got the equation of a line and the equation of a circle. And I'm told in question 7 that they do not intersect. And I'm asked to find the value of p, or show that p lies between two values. So let's start off by imagining we were going to find the point of intersection, and then we'll fix it so that there are no solutions. So if I was going to find the point of intersection, I'd start off by rearranging this formula by adding y to both sides. Give me y equals 3x minus 9. And then I'd substitute that value of y into my equation for this circle. So I'd have x squared plus px plus 3x minus 9 squared plus 4 lots of 3x minus 9 equals 20. All right. Now let's play around with this. Multiply out those, expand those brackets there. 9x squared, 9 3s are 27, so that's going to be minus 54x plus 81 plus 12x minus 36 equals 20. Brilliant. Right, let's tidy that up, shall we? So I'm going to have 10x squared. Now the x's, I've got px. And then I've got minus 54x plus 12x, which is minus 42x. I've got 81 minus 36. What's that? 81 minus that's 45. So that's plus 45 equals 20. Now, if I were going to solve this quadratic, I'd set it equal to 0. That's x squared plus px minus 42x plus 25 equals 0. And now I would seek to solve that equation. But we want to fix it, of course, so there are no solutions to this equation, which means that we want b squared minus 4ac to be negative. Now, before I do anything else, can I easily see what a is? Yes, it's 10. I can't easily see what b is, the coefficient of x at the moment. So I'm going to rewrite this, and I'm just going to factorize here. So now I can see very clearly how many x's I have. Now I'm in a position to use this inequality here and make sure that my discriminant is less than 0, because then there'll be no solutions. So b squared would be p minus 42 squared minus 4 times 10 times 25, and I need that to be less than 0. That means that p minus 42 squared minus, that's 1,000 by the way, has to be less than 0. So that means that p minus 42 squared has got to be less than 1,000. Now, of course, there are going to be two solutions to this, aren't there? There's going to be the negative square root of 1,000, the positive square root of 1,000. And because I'm dealing with a positive p squared on the left, I'm going to have the negative square root of 1,000 here. It's got to be less than p minus 42. It's got to be less than the positive square root of 1,000. Good. So that means if I add 42 to everything, I'm going to have 42 minus the square root of 1,000. It's got to be less than p. It's got to be less than 42 plus the square root of 1,000. Now let's have a look at the question and see what I'm supposed to be doing. I'm not far off. Okay, all I need to do is to simplify this third and write it as 10 root 10 plus 10 root 10. And I believe that I have shown exactly what the question wanted me to show. So that is my answer to number 7. Question 8. This line meets the coordinate axes at A and B, and AB is the diameter of a circle. Right, so let's find A and B. So where does this line meet the coordinate axis? Well, if x is 0, then y is minus 8. And if y is 0, then x is 4. So there are the coordinates of A and B. Now, A and B is the diameter of a circle, and I need to find its equation. Well, I can find the center of the circle by finding the midpoint of A and B. And how am I going to find the radius of the circle? Well, I'll find the distance from the center to point B. Why not? So the distance from the center to point B is going to be the square root of the difference in the x coordinate squared plus the difference in the y coordinate squared. So the distance from the center to B, which is the radius of the circle, of course, is the square root of 20. So now I can write down the equation of the circle: x minus the x coordinate of the center plus y minus the y coordinate of the center equals the radius squared. So square root of 20 squared is 20. That is my answer for question 8. Okay, question 10. I've got the equation of a circle here, and I'm told it meets the x-axis at these 2 points, at P and Q, and I'm asked to find the coordinates of P and Q. But if it meets the x-axis, then y is going to be 0. So I'm going to solve this equation when y is 0. So 0 squared is just 0. So actually, I've just got to solve that equation. Okay, so if I square root both sides, then I'm going to get x minus 5 equals either plus 6 or minus 6. And now if I add 5 to both sides, I get 11 or minus 1. So the 2 points where my circle meets the x-axis are going to be at 11, 0 and minus 1, 0. And that is my solution to question 10. Question 11. I've got this circle here, and I know that it meets the y-axis at those 2 points, and I'm asked to find the value of m and n. So if I'm meeting the y-axis, then of course x is going to be 0, isn't it? So I need to solve this equation. 0 plus 4 squared plus y minus 7 squared equals 121. So that's 16 plus y squared minus 14y plus 49 equals 121. Well, this is a quadratic equation. Actually, hold your horses. I think that I've been a bit foolish here to multiply out that bracket. So I'm going to go back to the beginning. 4 squared is 16 plus y minus 7 squared equals 121. Take 16 from both sides, and I get y minus 7 squared equals 1. What's that? 121 minus 16, 105. And now, look, I can just square root both sides. Y minus 7 equals plus the square root of 105, or minus the square root of 105, which means that y will be 7 plus root 105, or 7 minus root 105. Well, that saved me a whole load of algebra, didn't it? Not going down this road, but instead solving it in that way, as if it was like a completing the square question. So now I know my 2 points, don't I? I know that m can be the first of those, 7 plus root 105, and I know that n can be 7 minus root 105. Of course, if I'd gone down this road, I'd have ended up with the same solutions. I'd just have had to do an awful lot more algebra. So there's question 11 sorted. Question 12. I've got the equation for a circle here, and I'm told it meets the positive axes at these points, and I'm asked to find the value of little a and little b. So let's start with part A here. Let's start with little a. So little a has a y coordinate of 0, so I'm going to have x plus 5 squared plus 2 squared equals 125. Now it would be tempting to multiply out this bracket here, expand the bracket and take it from there, but that would be slightly foolish because I can solve it in this way. Look, root both sides, x plus 5 equals the square root of 121, which is plus 11 or minus 11. Take 5 off both sides, so x would be 6 or minus 16, but I know that I'm dealing with the positive axes, don't I? So I know that x must be 6, so little a equals 6, and a has the coordinates 6, 0. Okay, now let's find little b in a similar way. Little b tells me that's when x is 0. So I'm going to have 5 squared plus y plus 2 squared equals 125. So this time y plus 2 squared is going to be 100. So y plus 2 is going to be plus 10 or minus 10. So y is going to be 8 or minus 12. And again, I know that I'm dealing with the positive axes. So I know here that little b must be 8, and the point B is 0, 8. So I found A, B, and I've completed part A of question 12. Right, part B. I need to find the equation of the line AB. Right, well, let's write those two coordinates down here. I've got A is 6, 0, and I've got B is 0, 8. Right, part B. So I've got to find the equation of the line AB. Well, first of all, let's find the gradient of the line between those points. So I'm going to do 0 minus 8 over 6 minus 0, leaves over the minus 8 over 6, which is minus 4 over 3. And now I can use y minus y1 equals m, x minus x1. I'll use point A here, so I'm going to go y minus 0 equals minus 4 over 3, x minus 6. Multiply everything by 3. Multiply out that bracket, plus 24. Okay, I don't know why I've written 3x there, it should be 3y. So y is going to be minus 4 over 3x plus 8. And that is the equation of the line AB. And now for the last part of the question, I'm asked to find the area of the triangle ABC. Let's draw a quick sketch. So, sorry, I'm asked to find the area of the triangle OAB, right? O is the origin. Now, one of these points is 8 up. There we go, that's point B. And the other point is here, point A, and that's 6, and that's 8. So that's my triangle. So the area of the triangle is simply going to be 8 times 6 divided by 2. 6 8 is 48 divided by 2 is 24. So that is that question, question number 12, sorted. Question 13. I have a circle with a certain centre and with a radius of 25, and I know it meets the x-axis at those points. And I know that q is greater than 0. Let's have a look. So I can write the formula for the equation of my circle, which is going to be x minus p squared plus y minus q squared equals 25 squared. Great. Now, if I use my first point, which is the point minus 7, 0, then I know that minus 7 minus p squared plus, if I put in y as 0 there, I'm just left with q squared equals 25 squared. And if I use my second point, which is the point 7, 0, then I know that 7 minus p squared plus q squared equals 25 squared. Good. So I've got two equations, equation 1 and equation 2, in p and q. I'm going to subtract those equations now, because that will eliminate my q squareds. So I'm going to put a minus, a minus, and a minus. So I'm going to end up with minus 7 minus p squared minus 7 minus p squared. The q squares are going to go equals 25 squared minus 25 squared is 0. Good. So that means that minus 7 minus p squared equals 7 minus p squared. Now by inspection there, I can see that p will have to be 0. Okay, but if you wanted to, you could multiply out both left and right, do the same to both sides, and you'd end up with p equals 0. Right, so p is 0. So if p is 0, then let's have a look at, let's look at equation 2. If p equals 0 in equation 2, then I'm going to have 7 minus 0 squared plus q squared equals 25 squared. So that's going to be 49 plus q squared equals 25 squared. So q squared will be 25 squared minus 49. So q squared on my calculator is 576. So that means that q is plus or minus the square root of 576 is 24, plus or minus 24, but you're told that q is greater than 0. So q must equal 24. All right, so I've got p equals 0 and q equals 24. And the center of my circle is 0, 24. That's part A done. Okay, part B. So I need to find the points where this circle meets the y-axis. So let's first of all write down the equation of the circle. I know that the center is 0, 24, so it's going to be x squared plus y minus 24 squared equals 25 squared. And I need to find the points where this meets the y-axis, so that's going to mean that x is 0. So I'm simply going to have y minus 24 squared equals 25 squared. Square root both sides, y minus 24 equals either plus 25 or minus 25. Add 24 to both sides is going to give me y equals 49 or minus 1. So the points in question are 0, 49 and 0, minus 1. And that is part B of question 13 finished. Question 14. Right, I've got a circle with a centre 5, 1. Okay, and I've got a point on that circle. There's my badly drawn circle. Here's the centre, 5, 1. And the point A is going to be, say, here. Okay, and that is the point minus 3, minus 7. And I'm being asked for the equation of the tangent there. So what I'm going to do is I'm going to find the gradient of the line CA, first of all. So the gradient, the m of the radius there, the gradient of the radius. So it's going to be the difference in the y coordinates. So let's do 1 minus 7 over 5 minus 3, which is 8 over 8, which is 1. So that means that my tangent will have a gradient of -1, and my tangent, of course, goes through the point A, doesn't it, which is -3, -7. So now I simply have to use y minus y1 equals m times by x minus x1. Let's simplify that. Good. Let's bring it all onto this side, shall we? Y plus x plus 10 equals 0. And there is the equation of the tangent of that circle at the point A. Question 15. Now a diagram is going to be useful for this one. Let's have a look. I've got the point A, which is 3, 2, 4, 6, 8, 7. So there is the point A. And I've got the point B, which is -5, 2, 4, 5, -5, 3. There's the point B, A. Okay, and I've got the centre of a circle, which is at 2, -1. So that's the centre. Okay, I'm told that AB is the chord of the circle, and that AC is the diameter, and I'm asked to find C. So, looking at this diagram here, I could imagine this straight line here. It's going to go from A through the centre of the circle and down here somewhere, isn't it? And that's going to be, I don't know exactly where the other side of the circle is going to be, but I can work it out easily enough, because here, to get from A, I'm going down 2, 4, I'm going down 7 and along, going down 8, -1, that's the vector 8, -8, -1, so I'm going to go another -8, 2, 4, 6, 8, and another -1. So that point there is going to be the point C, where AC is the diameter of the circle. So let's just have a look at that with the figures. I had the point A, which was 3, 7. I used the vector -1, -8, -1, -8 to take me to the centre C, and so that gave me the point 2, -1. So I'm going to use that vector again, -1, -8, to give me the point 1, -9, which is this point here, 1, -9. So in answer to the first part of the question, which isn't really the first part of the question, but I found that C is 1, -9. And now I'm asked to find the area of this triangle here. There it is. Now there must be lots of ways of doing that. I'm going to do it in a kind of what I find quite straightforward. I'm going to find the area of this entire rectangle here, and then I'm going to subtract away the 3 triangles that I don't want to include. Okay, so let's have a look. So this whole width is from -5 to 3, so the whole width is 8, and then this height goes from 7 to -9, so the height is 16. So the area of the whole triangle is 8, the whole rectangle is 8 minus 16, and from that I'm going to subtract the area of this triangle here, which is 4 by 8 over 2. I'm also going to subtract the area of this triangle here, which is 1, 2, 3, 4, 5, 6 by, it goes from minus 9, 6, 12, isn't it? Which is 6 times 12 over 2. And I'm also going to subtract the area of this triangle here, which is 2 by 16 over 2. So all I'm going to do is to put that little lot in my calculator, and I get the answer 60. And that is the area of triangle ABC. Well done. That is the first part of the mixed exercise on circles done, questions 1 through to questions 15. If you've got any questions, please do leave them in the comments, and of course I'll respond and give you a hand. If you found the film useful, go on, tell me so, and hit like. And if you'd like to, please do subscribe to the channel. See you in the next film.